Welcome back to AP Statistics. This is Dr. Kling, still not affiliated with the College Board. This is kind of an optional lecture. I'm going to talk about the birthday problem. The birthday problem is, suppose we have 20 students in a class. What is the probability that at least 2 students share a birthday? So that's kind of a classic question. What is the probability that we're going to find a common birthday in a class of 20 students? So let me give you a strategy for solving that. Imagine we had these students here, and we take our first student, and we ask, does this student share a birthday with any other students? And if the answer is yes, we stop and say we're done. We found a case where there's a shared birthday. If not, we get rid of this student in some sense, and we go to the next student, and we go, does this person share a birthday with any of the remaining students? Here. And again, if we say yes, we stop. No, continue on to the next student. And now we'll ask if this student matches with any of these remaining students. And we keep doing that. And if we get through all the students, if we go along this path and we get all n's, then we have finally gotten through everybody without finding a match. And so if we take 1 minus the probability of getting all the way down this path with all n, all saying no, then that'll be our answer. So now we have to figure out what the probability is of going down this path. And we said so think about that first student. So we have 19 students that we could potentially match with, and each student has a 1 out of 365 chance of matching. So our chances of not matching with all those students is 364 over 365 to the 19th. That's our classic 1 minus p to the n, which gets us here. Okay, so 364 over 365 to the 19th is the probability that we don't get a match for any other student with the first student. So that's sort of like no along the first branch of the tree, and now we go to the next branch. In the next branch, I was going to say it would be, since I've taken a student out of the room, it would be 364 over 365 to the 18th. Then one of my students pointed out that that's actually not going to be right. That what I'm going to have to do is not just take a student out of the room when I move on to the next student, but I also have to take a birthday out of the picture. So when we're down to 19 students left, and so I'm taking the second student and comparing to the other 18, I only have 364 possible birthdays. And this would get to be very important as we got close to having, let's say, 365 students in the class. This is the way we would ensure that, if you got to 365 students, you would absolutely get a match. So we decrement the 364 down to 363 and the 365 down to 364. So so that's for the second student not finding a match. And then for the next student, we can see what the pattern will be. It will be 362 over 363 to the 17th for the third student. And then we want to take all these things, let's go back up a little bit. We take this times this times this all the way down the line until we finish trying to match all the students, and that'll give us the probability of no match, and then we take 1 minus that, and that's the probability of a match. And now I'm just going to show that on a spreadsheet. Okay, so I set that up here, and I start with, I call it student number 20. I calculate the probability that student number 20 has no matches with anybody else. And then I go on to student number 19, number 18, and so on. Then take the product when I finally get down to the bottom, and then take 1 minus the product, and that's the final answer. That means that there's a 59% chance of finding no matches, and that means a 41% chance of finding a match. So we see that our final answer is that there is a 41% chance that we'll get a match with the birthday. So that's probability of finding a shared birthday equals about 0.41 in a class with 20 students. Okay, and that's it. See you next time.